Good morning again, everyone. Morning, morning. Hope your day is going well so far. Welcome to our new and returning attendees. Thank you for joining today's Spatial Innovision webinar. Today's topic is creating smart cities using digital twin, but Hopetown added the lovely and transforming our world. But digital twin is a wonderful, very useful application powered by GIS, which we all have come to love. Our presenter today is Mr. Hopeton Ferguson. He is the Vice President of Strategic Solutions at Spatial Innovision. And I am Matthew Webster, Vice President of Corporate Services here at Spatial, and today's session moderator. Now, today's session will focus on our rapidly developing digital world and the benefits of utilizing this digital twin to solve growing business challenges. Digital twins create relationships and streamlines workflows by improving business processes, optimizing operational efficiencies, and reducing risks and enhancing decision making. At the heart of digital twin is the GIS application. And again, we all love GIS. And as GIS continues to create digital twins of the natural and built environment, we will delve into how this technology can be applied in a local Caribbean context, thus enabling the creation of smart cities. Now, should you have any questions or comments during the presentation, we invite you to use the Q&A feature, the comment box. You can even raise your hand as well, and we can acknowledge those. And we'll attend to each of them accordingly. And we want it to be an interactive session where we can answer whatever questions or even comments you may have. And with no further ado, I'm going to invite Hopeton to begin his presentation, starting off with the agenda. Hopeton.
Thank you, Matthew, and good morning to each and everyone today. Welcome to Spatial Innovision series of 2022 webinars. So my name, as Matthew has mentioned, is Hopeton Ferguson, and I'm the Vice President for Strategic Solution at Spatial Innovision. Today, we will be talking about using digital twins in our organization and in transforming our world. So we will first take a look at the definition of digital twin, the why of digital twin, then take a look at digital twins worldwide, followed by ArcGIS platform role in transforming the world through digital twin. And this will be followed by examples of digital twins in the Caribbean, in particular Grenada. Then we'll have some questions and answers. If you are okay with that, please show some love. Let me see some love. Show some love by showing the heart. Not seeing any love, man. What's happening?
Looking for the love, sir. I'm looking for the love there. Oh, I see hands raised. So maybe
All
that's
right.
the love.
we will work with that.
All right.
All right. Digital twin. If you have heard of digital twin before, or should I ask, what comes to mind first? Just put your hands up or type in the chat. What comes to mind first when you hear the term digital twin? So I'm sure at some point you'd have heard, maybe since you have seen the ad going out. Okay, BIM. All right, I've seen Jonathan Weeks. Yes. Any other? Nothing. All right. That's okay. Hopefully by the end of this presentation, something will come to mind. All right, great. So we're going to kick off by looking at digital twin. What is digital twin? So a definition for digital twin would be the virtual representation of the real world, including physical objects, processes, relationships, and behaviors. So GIS creates digital twins of the natural and built environment and uniquely integrates many types of different models. So at this time, we are going to take a quick view of a video on digital twin to explain to us a little more as to what it is.
Not hearing any sound with your presentation open.
Okay, let me.
Yeah, you might have to reshare your screen with sound.
Yes. Let me do that.
Yeah, man. Sorry about that, guys.
All right, so let us start back that. Right. So now we know that digital twin can be used in any and every aspect of our life. Even the surgeon can use digital twin. Does that make it any clearer for you as to what digital twin is? All right, at this point, we're going to look at why do we need digital twin? So digital twins provide land use optimization. It replicates design plans, provides smart maps and geofencing data, audit progress, simulate mobility and traffic, monitor climate change, submit building permits, analyze zoning, and oversee environmental and other compliance. And these are just a few of the reasons why digital twin. So at this point, we're going to look at another video. And this video will tell us more about the digital twin of the world. So just sit back, sit tight as we watch this video on digital twin and what's happening right around the world as it relates to digital twins.
Today, governments are partnering with tech players to build a digital twin of the physical city. Singapore, for instance, has invested $73 million to create a digital replica of the actual city. Now, how cool is that? The objective is to help make urban planning decisions and communicate with its citizens. A similar endeavor is happening over in India. The government is using a digital twin just for the development of a smart city capital for one of the Indian states. Why leverage the digital twin? With the help of the digital twin, it will provide a land use optimization, replicate design plans, smart maps or even geofencing data, audit progress, simulate mobility and traffic, monitor climate change, submit building permits, analyze zoning, and oversee environmental and other compliance. Basically, the digital twin can help with urban modeling and planning, and it can combine spatial, electrical, and mechanical modeling with sensor data. Now let's look at one more city. Earlier this year, a digital twin was developed in Western Sydney. It's Australia's built and natural environment. The open platform can visualize 3D and 4D data over time. Here, an infrastructure developer can locate utilities very easily. The government can better communicate plans for development to citizens. Growth is expected too. ABI research says urban digital twin deployments will grow from a handful of early implementations just last year to more than 500 by 2025. To better understand, let's look at one more specific area of city. I want to focus on transportation. The digital twin is having a big impact on transportation and how we can understand and actually visualize it. There's really some big value in being able to expedite large-scale transportation projects. And there's benefits that city officials need to take into account. Having analytics and aligned data gives all of our city officials the ability to look back and scrutinize the impact of all of these projects. Another factor is more being able to expeditiously look at a roadway project that is completed and how they're able to shorten the impact on goods and services for businesses. With the digital twin, city services can get up and running faster. The future of digital twin in cities is growing rapidly in other parts of the world. IDC forecasts smart city spending will climb almost 19% by the end of this year from last year. Singapore is the top investor, with Tokyo, New York City, and even London following closely behind. Last year, the top use cases were related to resilient energy and even infrastructure. In the next 5 years, you can expect use cases with the fastest spending growth will be vehicle-to-everything connectivity, officer wearables, and of course, you can expect the digital twin. Early adopters are setting the pace, which makes it truly an exciting time to get involved in the digital twin if you're already not involved. So if you haven't already taken notice of what is happening with the digital twin in our smart cities, perhaps you might just set some time aside to get caught up, because you just might be leading a digital twin effort for your company in a smart city near you.
All right. So let us all get involved in this digital twin. You might create one of the best digital twin in the entire world. So we see what is happening right around the world, and we need to also get on board in doing our digital twin. So digital twins are really transforming the world. If you could just at this point put in the chat some ways that digital twin can be used in your organization, that would be good. Let me pause for a minute while you place in the chat as to how your organization can use digital twin. So you can type in the chat if you haven't started a digital twin yet, then just put in the chat how your organization can use digital twin. How is that coming on, Matthew?
Haven't seen, well, Elton Sampson says for mining machinery models.
Awesome. All right. Love that one. Anyone else?
I'll take it that they're probably still typing.
Okay, let me give you one more minute.
All right, so Terry Innis says he's in a water utility and he wants to know how that would help us.
Okay, awesome. All right. Hopefully by the end of this presentation, then you will know. All right. So you can continue typing, and while I just continue the presentation. So did you know that the ArcGIS platform is a very powerful tool in transforming the world through digital twin? I'm going to tell you a little bit more as to how this is done. So in looking at the ArcGIS platform, which is transforming our world through digital twin are actually abstracting and modeling everything. From the landscape, we have the land information model, or we would call it LIM, or terrain, and the natural environment buildings. We have the building information model, which is the BIM, and this is with facilities and structures, and we talk about the indoors. We also have the network through the network information model, showing utility pipelines, roads, and highways, and we call that the NIMS. There's also the city information model through smart cities and city planning, and we call that CIM, city information model. So the integrated digital twin is interconnecting contents, behavior, and workflows. It's impacting designs and engineering, smart cities, natural resources, asset management, sustainability through the BIM and the LIM and the SIM and the NIM, as we just talked about. It is enhancing business processes, communication, decision-making, and collaboration. GIS is also interconnecting and integrating by creating relationships and streaming workflows. It captures and integrates data, visualizing real-time, predict and analyze, and share and collaborate. And we'll talk some more about that. So data capture, integration, and management looks at data types such as the 3D objects, LiDAR, mesh, extrusions, while data model can be in the form of 2D or 3-dimension BIM, allowing integration and management. In terms of dynamic visualization model, this enhances real-time awareness and decision-making through visual trends. So interactive slides and data-driven 3D, GIS creates capabilities such as dashboards and reporting, real-time IoT integration, insights and analytics, and advanced visualization. Then we have the GIS providing insights for future outcomes by transforming digital workflow. So this is done through classification, machine learning, AI modeling, and predictive modeling. And we'll talk some more about this later. Also, it helps us in sharing and collaboration through GIS engaging the community. This enables better communication and engagement through website events and citizen collaboration. So digital twin has become so necessary over the years as it drives down the high cost of recurring updates, increase efficiency, sustainability, accountability, and transparency, and simplify communication between or among organizations. So at this point, we're going to take a look at the Caribbean and how digital twin is impacting the Caribbean. So this will be a demonstration. It's going to show you a visual journey of Grenada, and this is through the eyes of the digital twin. This is actually a project in collaboration with Grenada Central Statistics, the Ministry of Agriculture and Lands, and also Esri. So Grenada, as some of us will know, is a very beautiful island, and it's made up of several other little islands with a total area of 348 kilometers square. So it is a great place for agriculture known as the Spice Island and tourism also. However, it is also known for its natural disaster. So at this point, relax as we take a tour through the digital twin.
Let's fly into Grenada and interact with both the original sensor data and the derived GIS content that makes up the 3D digital twin of the island. The initial elements are aerial imagery and the elevation surface, plus the dense LiDAR point cloud content being shown on top of it. This data all came from the recently acquired aerial survey for the island, and it serves as a foundation for Grenada's 3D base map. LiDAR points look realistic when showing the captured RGB colors, but they become more powerful when they are classified into the type of objects that they've hit, be that vegetation, building, or power line. With classified LiDAR, GIS features can be extracted from the point cloud. Individual buildings can be identified and assigned an address and an owner, as well as an estimated location and size of trees, and then these can be used to plan for a more resilient future. For example, we can model a 4-meter storm surge and see what it might do to infrastructure. A virtual world can be used to model and analyze real-world problems before they happen. Analysis can be run on the derived elevation surface from the point clouds to detect potential hazards such as landslide areas. As we fly along and see where landslides are more likely to occur, the 3D base map helps us understand the potential risk to people and property. And such analysis can be scaled out for the entirety of the island. The same is true for flooding potential from rivers and waterways. Knowing where they are, how they could spread out in a flooding situation, and what buildings and power lines could be impacted helps with better planning and risk management. Tourism too can be served by highlighting hidden gems like Grand Etang Lake. A digital twin model, connected with the expertise of people who understand what potential disasters and planning challenges the island faces, allows the nation of Grenada to plan for its future in the best way possible.
All right, so we see Grenada is going on with things, man, with their digital twin. This looks like fun, eh? Are you having fun? Just put some love in the chat. So at this point, we'll look at the step-by-step process in creating a digital twin. We would want you to create your own digital twin. So we're going to take you through the process as to how the Grenada digital twin was created. Now, this is actually started by using some very high resolution LiDAR data manipulated in ArcGIS to get the desired result. So let us invite Kate and Amanda to demonstrate to us the use of the ArcGIS tool in creating digital twin and talk a little about some end uses and application in our daily work activities. Kate, take it away.
So the 3D scene that you just saw in the video there was combining many different output products that we've generated from the raw imagery and the LiDAR data. I'm going to go through how we made some of those products, and I'll start with the 2D story to look at what we created from imagery and how that came together to form the digital twin. To start with, as Linda mentioned, we received the high-resolution imagery for the whole country of Grenada. And looking here, you can clearly see the building rooftops and other features like roads, which we're going to extract using deep learning. We also received elevation data, like this hillshade, which we created from the digital elevation model. And we can use this to identify drainage patterns and model flooding and landslide risk. The goal of our project was to take this raw data and derive from it layers and datasets that will be useful foundational GIS for the Grenada government to use for urban planning, emergency management, natural disaster preparedness, and as a base for their census. Hosting and analyzing large volumes of imagery data was vital to the creation of the digital twin. We used ArcGIS Online's hosted imagery capabilities and performed all of our advanced raster analytics in the cloud. Let's zoom back in to look at the high-resolution imagery and see how we can do the raster analysis on this imagery online. We're going to use deep learning to extract the building footprints, saving us from weeks of manual feature digitization. We can do this using the Detect Objects Using Deep Learning tool. And all we'll need to do is input our imagery and then select a deep learning model to use to detect objects. We're going to use one of the pre-trained deep learning models available through the Living Atlas. So for this imagery, we used the building footprint extraction model that was trained on USA data. We have another version that was trained on building footprints in Africa that we could also use depending on our area of interest. And today we'll use this building footprint extraction model without adding any additional training data, but that is also an option. Running the tool out of the box, we'll get this output. And you can see that we've successfully identified building footprints for the entire island. This process took about a day to run, saving us a lot of time of manually digitizing these building footprints. With our other deep learning models, but using that same tool in ArcGIS Online, we were able to extract roads, as you can see here in the dotted line. And when I zoom out, we can see the land cover classification that we also performed using a deep learning model in ArcGIS Online. Next, we used the ArcHydro tools in ArcGIS Pro on our DTM data, so the elevation data that I was showing at the beginning. And from here, we were able to extract highly accurate streams, as well as flow networks, which are key inputs for flood modeling. From here, with these layers, we can start to do more complex analysis. For example, identifying areas susceptible to landslides. Within ArcGIS Online, we can perform raster analysis. So if I open up the raster function editor, I can see in the Living Atlas or in ArcGIS Online that there are hundreds of different raster function chains available to you. So you can use these as they are or customize them to your analysis. I created a landslide susceptibility model. And you can see here we've chained together a series of raster functions, including calculating the slope from our DEM and taking into account our rivers with a distance function and that land use that I did using the deep learning model for the classification. When I run this model, I get a landslide susceptibility layer for the entire country. With a similar process using another model, we were able to calculate flood susceptibility. You can see in red the areas that have been flagged as being highly susceptible to flooding. We can update all of these outputs in a year or in a few years whenever there's new imagery available, using the same methods with the pre-trained deep learning models and the raster function chains. And that way we'll be able to see how the island is changing over time. We can continue to work with all of this data in our 2D maps, running additional analysis, creating buffers, doing travel time analysis, etc. But this becomes even more powerful with the added context of 3D. Even without LiDAR, we can bring the layers that we've created from imagery into a 3D scene. So I can take a look at that landslide susceptibility layer overlaid on an elevation data and see how it lines up. And then we can add those building footprints that we extracted. To bring them even into 3D without any LiDAR data, we can perform a 3D extrusion. So we can set the number of meters that the buildings are going to be extruded to above the ground. So I can change it to 10 if I want to make them a little bit taller. We can build this out further, making the buildings look realistic by pulling colors from the underlying imagery. But already, just from our imagery data, we were able to create a digital twin that we can start using for urban planning, public safety, emergency management, and more. With the addition of LiDAR data, our digital twin can be made even more accurate. I'll pass it to Amanda now to show how we extracted additional features and insights about Grenada from LiDAR data.
Awesome, thanks, Kate. Here, I'm in ArcGIS Pro, and using what was provided to us by the country of Grenada, we started with LiDAR points that were already classified as buildings. And even though there are tools in ArcGIS Pro that can help us classify all of the buildings from the LiDAR, the vendor had already done this part very well. So, to first generate 2D building footprints, we decided to use the 3D base map solution to process the LiDAR points, and then use those footprints to generate the 3D building features. Looking at the 3D base map solution, there's a set of easy-to-use tasks that are specifically designed to help guide you through the process of creating different 3D representations from LiDAR. In this example, we needed representations of buildings and trees. So we ran the process called Create Buildings in order to automatically create 55,000 building footprints using those LiDAR points that were classified as buildings. From there, the building footprints were then regularized so that the sides of each building would either be straight, angled, or circular. Once that was complete, we then used the elevations that were generated from the LiDAR to automatically create 3D buildings from 2D building footprints. The 3D building roofs were then colored from the imagery, and side colors were applied at random based on photos of Grenada's capital. As for the trees, those were also created using one of the 3D base map tasks to extract tree points using surface analysis of the LiDAR, and then further selected using a normalized difference vegetation index that indicated the differences between trees and other tall features. With this, a total of 4.5 million trees were collected across the islands of Grenada. These can be compared with LiDAR collections in the future in order to determine any tree growth, tree reduction, or tree height differences in areas that have trees. Additionally, a topographic map was then created of the entire country of Grenada. And by using a tree canopy that was created by creating a tree canopy that was generated with height from the LiDAR classified as trees, as well as the normalized difference vegetation index based on the imagery, the basis of the topographic map was formed. Topographic contours were derived from the LiDAR and smoothed to be cartographic. Rivers were created using hydrology tools from the digital terrain model, and the building footprints were added from the LiDAR extraction. Spot elevations were then generated using raster functions from the digital terrain model and scaled so that less points and less contour intervals would be shown as you zoomed out. This data will be added to the World Topographic Map, as well as other existing base maps that are part of Esri's Living Atlas, making it easily accessible to the country of Grenada. Here, I'm showing you the different scales going from 1 to 2,000 up to 1 to 20,000 to show how the spot elevations, the contours, and how the features would all look in the World Topographic Map once they're added. So now that you've seen how the various components of the digital twin were created, let's look at some potential applications of this data for real-world scenarios. First, 3D twins are a powerful tool for natural disaster resilience. For example, we can use the digital twin as a base for flood and storm surge modeling to help us see exactly which buildings and which infrastructure would be impacted in different scenarios. To help us do this, we have the ability to compare what 1 meter of sea level rise would look like, which is what I have it set at right now, to even viewing what 3 meters of sea level rise would look like. From here, I can see exactly which buildings and which roads might be impacted by 3 meters of flooding while zoomed in and panning around the area. Here's a closer look at how this area would be impacted by a scenario like this. We can also run a model to identify which areas are low-lying and considered susceptible to the impact of flooding with a combination of data, including the vector stream dataset, multispectral imagery, rainfall data, as well as terrain derivatives. This is our flash flood susceptibility map, and on it, the high-risk areas are highlighted in red. We could use information like this to take action, such as using it to generate an evacuation plan in order to help guide citizens to shelters for safety. This is just one example of how a digital twin can really enable us to better prepare for potential natural disasters like flooding and storm surges. But there are other natural disasters that a digital twin can help us prepare for as well. For example, GIS can also help Grenada prepare for and respond effectively to landslides. We can use raster datasets like soil type and 3D measurements such as slope and aspect to anticipate which areas may be at greater risk of a landslide occurring. This is the output for the entire island, and all of the areas that are more susceptible to landslides are highlighted in orange. These calculations can inform efforts to fortify and protect susceptible areas of the island against landslides, such as an area where there are buildings on a hillside in a high-risk area. We can use extracted data like roads, buildings, and landslide susceptibility to help improve planning and response on the ground for first responders. These two disaster preparedness scenarios for floods and landslides are just some of the advantages of a digital twin and how they're a powerful tool for natural disaster resilience. Outside of natural disasters, another sector that can benefit from GIS is the management of critical infrastructure. So for this one, I'm going to jump to Carriacou and look at the power lines that were extracted from the LiDAR. Here, I can pan around the entire scene and begin to explore the area more closely, looking for places where there seems to be some vegetation encroachment on the power lines. And from the looks of it, right here along the coast, there's one area in particular where it looks like there are a number of trees that are actually getting pretty close to the power lines. The closer I get and the more I pan around the different angles, I can confirm that it does look like there are a few tree branches that are nearly touching some of these power lines. And because of that, this is probably an area that we would want to go ahead and send a maintenance team to in order to help clean it up a bit. This is an example of how digital twins allow us to be more responsive. And so far, we have talked about how the digital twin can enable us to anticipate and to react. But this technology also enables Grenada to plan and to grow. And what I mean by that is that we can use data sets such as land cover classification along with the extracted buildings and roads to help us identify areas for potential new development. For example, if I were to zoom in over here, we can clearly see that there's an area that's been identified as having low vegetation, while also being in close proximity to roads and other buildings too. Essentially, we have the ability to visualize whether or not it would be easy to work new construction into this already existing infrastructure. Turning off the land cover, I can see more clearly that this is, in fact, an area that we wouldn't need to cut down as many trees in order to put a new building or new housing development. In this way, digital twins can enable sustainable and efficient urban planning, while also minimizing negative impact on the environment. From natural disaster resilience against floods and landslides, to the management of critical infrastructure, to enabling sustainable and efficient urban planning, there are many benefits of a digital twin, enabling us to do more with less.
Okay.
So the 3D scene.
All right. So now you know all about digital twin and how to create digital twin. So we'll be seeing a lot of digital twin going around as of now. Looking forward to see that. So at this point, we're going to do a quick recap, and then we have some question and answers. So first of all, what is digital twin? I know some persons might have come in a bit late. So digital twin is a virtual representation of the real world, including physical objects, processes, relationships, and behavior. And GIS allows us to create a digital twin of both the natural and the built environment. Why digital twin? Digital twin because of land use optimization, replicate design, smart mapping, simulation mobility, monitor climate change, building permits, zoning, environmental compliance, and more and more and more. So ArcGIS transform the world through digital twins. So using ArcGIS, you can create a number of digital twin. And the beauty of it is that GIS interconnects and integrate the data you capture and do it in real time. So you can actually have real-time visualization. You can analyze and predict, you can share, and you can collaborate. So there is a whole lot of benefit to creating your digital twin. And we just want to see how best we can get going in doing our digital twin. Now, the question was asked, how can the water industry use digital twin? I'm sure the water industry has assets, and you can use digital twin for asset management. You can actually see in 3D what's happening out in the field. It might be a pump, it might be whatever it is. You can actually see, and you can if you're connected, you can actually operate what's happening out the field from in the office. So there are many uses. That's just one, and we can talk to you more about it and see some of your requirements and see how best we can meet it. All right. All right, thank you very much for that. And this time I turn back over to Matthew for question and answer.
Thank you, Hope Ton. So I know during the chat, there were people commenting and going along, so that they were enjoying the presentation. We had gotten one question to the question and answer, and that was regarding the availability of the slides after the presentation, which I had responded to. So the presentation, we are going to upload it to our YouTube channel as we normally do. And then we'll send out an email to all attendees, all registrants, those who could come and those who couldn't come, with a copy of the recording, so that you can go online and watch it there as well. However, you can let us know if you have any questions at this time. And if not, then, I guess we can close off a little early and, go about our day. So I'm gonna leave the floor open for about another minute.
I have question. When I see a question coming in,
okay,
so we can deal with that. I have some questions also.
All right, so I see one from Jonathan. So let me address that one, and then we'll do yours. All right, Open?
Sure.
All right, so Jonathan asks, can digital twins be used with mixed reality technology? And if yes, does ArcGIS currently provide a streamlined workflow for that?
Wow, awesome question, Jonathan. Let me research that one for you. I know digital twin, as it relates to virtual reality and so on, definitely can be used. Digital twin can really be used in so many different aspects of life and different technology, integrating and giving you the best output. But let me do some more research on it and give you a better answer than this. All right, Jonathan?
All right. And one thing so Jonathan responds with, okay. One thing I'm realizing, can you just share with the attendees your email address just in case they want to reach out to you?
There you go.
Yeah, I'm going to type it in the chat as well so that they can see it.
Right.
As well. So Hopeton's email is vpgeospatial@spatialvision.com, and our contact numbers, I'm going to put that in the chat as well, just in case you want to call our offices for any questions. I'm going to put that in the chat as well. Another question. Does Spatial Innovision have scope for GIS professionals to work on digital twin projects?
Oh, yes, definitely. We have a number of persons who are certified in the ArcGIS, and we definitely can. Also, we have partners who we can work with. So yes, we do.
Right, so that would answer Elton Sampson's question. All right, Hopton, you can jump to your questions in the interim while I put the contact numbers in the chat.
All right, awesome. So my first question is, do you currently use GIS in your organization? I think that was one of the questions that you would have answered when you register, but you can just put in the chat a yes or no. We'll know. Or better yet, you could put yes, we use GIS, or no, we don't use GIS. All right, so that's question number one. Question number two, while you put that in the chat, is where is your organization in the patterns of use? So the patterns of use would be mapping. Do you use it just to map and visualize information? Or do you use it for data management? Or do you use GIS out in the field? We call it field mobility. Or do we use it to monitor our operation? Or do we use GIS to do analysis? That's creating new information from the information that you have. Or do we use it for design and planning? So when you are about to undertake a project or a task, then you can design and plan using GIS. Or do you use it for decision support? So with all the information together, you make certain decision as it relates to your organization. Or do you use it for constituent engagement? You know, that is communicating and getting information out. Or do you use it for sharing and collaboration? So do you share your GIS data? Do you collaborate with other organizations? So that would be question number two.
All right, so we have a few more answers from Mr. Sampson. He said yes, his organization uses GIS software and it's for maps, visualization, and limited analysis.
Awesome, awesome. Then another question I have, would you like a digital twin in your organization? And how would you apply that digital twin? Any answer for that question? Would you like a digital twin in your organization?
I haven't seen anyone to that one in particular.
All right, I think they're still thinking about it. And the final question I have, and this is related to if you need a digital twin in your organization, how would you like Spatial to assist you to get you going, get you started and get you going? Because we're here to help. Yes, Matthew.
Brian Austin from UDC says yes.
Hey, Brian.
Yeah, and Mr. Sampson says no, knowing of digital twin. He says yes, but he would need to learn some more. So definitely an opportunity for you to pick up that conversation, Hopton.
Awesome.
All right. So I'll get his contacts for you, and you can have that conversation.
All right, sounds good. Sounds good. I think that's it for me and the questions.
That's it. All right. If we have no more questions, we are wishing everyone a great day, a great week. And June is still fairly early. We're in our second week of we have another 3 weeks in the month. So we're also wishing you a great month. We can also look out for our next spatial webinar that is happening on the 29th of June. So that's the last Wednesday of this month. And that webinar will be focusing on the upcoming Esri User Conference. Getting prepared for the Esri User Conference. The user conference is now physical again. It's in person again, happening in San Diego like it used to. Not virtual for the past pandemic years, if you want to call it those. So there are physical in-person activities again happening. So our next webinar will cover everything that you need to know. And if you do have any questions about it, at this time, however, you can always reach out to us as well, and we can also help to guide that process for you. With that said, thank you very much, Hopetown. It was a very engaging presentation. The videos were very awesome. You shared a lot of information. Also saw where people said that they were enjoying it as well. So thanks for this. And the recording, as I said, would be on our YouTube channel, but that would also be sent out to you all by email. So you'll see that as well. Thanks for your time. Thanks for joining us, and we'll see you at the end of the month. Bye, everyone.
All right, everyone. Bye, and thanks for joining. Take care. Bye.